Hi, grade 12s, and welcome to Electrochem. I'm going to be doing the questions from the homework just so that we're all on the same page. So starting off with page 467, number 2, we're going to have magnesium, and because there's no state with it, we're going to assume that it's solid, taking it off the periodic table, plus aluminum sulfate. Sulfate is 2 charge, aluminum is 3 charge. So I need 2 aluminums with 3 sulfate, aqueous. I guess I can just do a forward error now. And what magnesium is going to kick out aluminum to form magnesium sulfate, aqueous, okay? And as you can see, magnesium is 2 plus charge, sulfate's 2 minus, and so they cross out to just magnesium sulfate that way. So we have to balance everything else out accordingly. Okay, and so that should be balanced there. B, I'm giving ourselves lots of space because we have number 3 and number 4 to do. A solution of silver nitrate. I know. We're going to assume all nitrates are aqueous plus metallic cadmium. And then we're going to react those two. And actually, I don't know offhand what cadmium charges. So it is 2 plus. Okay, so when it reacts, we're going to have silver becoming solid plus cadmium nitrate aqueous. And so we need 2 of these and 2 of these. Okay, so it says for number 3, identify the reactant oxidized and the reactant reduced in each reaction in equation 2. All right, so I'm going to do the numbers in blue. Anything that is in its elemental form is going to have an oxidation number of 0. Okay. Then you're going to look at your polyatomic ions. So polyatomic ion is always going to be -2, -2, is as long as it hasn't broken down. Like if the sulfur has broken down from the oxygen. And then these are just going to be as they appear and their charged form off the periodic table. Okay, so aluminum has a +3 charge, magnesium has a +2 charge, whereas in their elemental form, when they aren't an ionic compound, then they are neutral, they're 0. So same here, this one will be 0, this one will be 0. Nitrate's always -1, and so that makes silver +1 with the nitrate, +2 with the cadmium. So it's saying identify the reactant that's oxidized and the reactant that is reduced. We have to connect these two. So magnesium goes from 0 charge to +2. So that means it's loss of electrons, or LEO. This is oxidized, right? And I always think of oxidized species as their numbers are going up, so from 0 to +2, whereas aluminum is going to be reduced because it was +3 and now it's been reduced to 0. And that one, it confuses students because your number is going down but you're gaining electrons. So Leo the line says GER, so gain of electrons is reduced. That's what the GER stands for. So do you see I'm always, in this case, I'm always connecting the species that have seen a change in their oxidation number. Let me do it in a different color for this. This one, let's do it in just black. Okay, so silver or nitrate was -1 on the reactant side, it's -1 on the product side, so we don't change anything. Whereas silver, we're gonna see how it's going from +1 to 0. So this one is going to be reduced, okay? So it's gaining electrons. It's going from +1 to 0, so reduced. Whereas cadmium will be losing electrons. This is oxidized. Okay, so the more reactive metal in these single displacement reactions is always going to be the one that gets oxidized. So that's number 2 and number 3 taken care of. And then number 4, it says identify the oxidizing agents and the reducing agent in each reaction. Now this is where it gets even more annoying. The species that was reduced is the oxidizing agent because it causes the oxidization of magnesium. And so magnesium is oxidized, and so it is the reducing agent because it causes the reduction of aluminum. So this one, oxidized, this is reducing agent. This is reduced, so this is oxidizing agent. Oxidizing, if only I could spell. And voila. Okay, what else did I give you guys? So page 468, the next page 6 to 7. Oh, I just realized we were supposed to do for these the total ionic equation and net ionic equation. I'm just going to show you the net ionic equation. Okay. And so the same thing is going to happen there. It's just that the sulfates are going to be, and so this is really easy to see that magnesium is being oxidized and aluminum is being reduced because you can see the two charges. So I apologize for not doing the net ionic equation. Okay, and so we're doing numbers, okay, looking at this half reactions, so 6 to 8. 6A is iron solid plus copper 2 plus aqueous. So even though I made the mistake on the other page, I can show you what we're doing here. Okay, so we're connecting these two, iron and iron, copper with copper, regardless of the charge. And the way that we have to balance the half reactions is we have to include the number of oxygens. So iron here loses 2 electrons, whereas copper up here gains 2 electrons. So because both half reactions, they're both going to involve electrons. So for iron, we're going to have iron solid is going to become iron 2 plus while giving away 2 electrons. And then copper 2 plus is going to gain those 2 electrons and become copper solid. Okay, so this is the flow of the electrons. I forgot the 2. So because this is 2 and 2, these are balanced, right? If it was any other number that wasn't the same between those two, then you would have to use coefficients. So let's see. The next example, 6b, we're going to have to use coefficients. So we have cadmium reacting with silver. Okay, and it's actually already balanced for us. I know this because of these coefficients. They're trying to help you guys out before trying to guess it on your own. So cadmium is connected with cadmium, silver is connected with silver. So cadmium goes from 0 to 2 plus. And so that is going to be, if your number is increasing, that's loss of electrons. You're losing some of your negativity. And so there's 2 electrons here. So this one is going to be gain of electrons, and silver goes from +1 charge to 0. So it's only 1 electron that it's gaining. So that's why we have those two coefficient of 2. So we have cadmium solid is going to form cadmium 2 plus aqueous plus 2 electrons. And then 2 silver ions is going to react with 2 electrons to form 2 silver precipitates. It's very solid. Okay. For number 7, write balanced half reactions for the following reactions. So this is where we're going to keep it all together. So we have tin solid plus lead 2 chloride. It's reacting to form tin chloride plus lead solid. So let's go in black and let's label all of our oxidization numbers. So elements in their elemental form is always 0. So that's tin solid and lead solid. Halogens are almost always -1. And if you can see, in this case, lead requires 2 chlorides to neutralize its charge. So it's +2 and +2 here. Okay, that would be the charge that you would, like, I would name this lead 2 chloride because its charge is +2. This is tin 2 chloride because its charge is +2. You guys know how to figure this out from grade 10 and whatnot. Now we have to connect that which is being oxidized and reduced. So you can see that there's a change in number for tin, and there's a change in number for lead. So tin is going from 0 to +2, so it's losing electrons. It's losing 2 electrons. And this is gaining electrons. It's gaining 2 electrons. So when you write the balanced half reaction, okay, you're not involving the chloride because it's not changing in any way. It's not part of the redox reaction. It's not being reduced or oxidized. Whereas lead over here, lead is being oxidized. Sorry, I wrote this one wrong. Tin is going to lose 2 electrons and become plus a cation, and then lead is going to gain the electrons and become solid. It's being reduced. Okay. Should I do one more? That one's going to, all these ones, the other ones are pretty similar to this one. So I'll let you guys try those on your own, and then you can always find the answers in the back of the textbook as well, or you can message me and let me know how things are. So hopefully you guys get this, and let me know if there's any other way that I can help you guys.